Okay, so now here's level 2 type of questions, kind of a variation of what level 1 was about. So let's say, for instance, I have something like this. I have two radicals that are trying to be multiplied. Well, if you remember the key concept of product property of radicals, you can split things up. You can also put things back together. So if I have the square root of 2 times the square root of 8, you can really say that this is the square root of 2 times 8, which is 16. And this happens to be a perfect square, which my answer would be 4. Okay, so that's pretty much it there. Now that's a pretty easy level 2 type of question. But let's take a look at another example. So remember, in this example, these two were inside the radical symbol, and that gave you that product within there. So here, these two terms are inside the radical symbol. Those are the two things that I can multiply together. The 4, however, that only gets multiplied with this Ninja 1 that's out front. So this is going to simplify to 4 radical, and then you just multiply everything that's inside here. So we're going to go 3x squared. Now if I'm looking at this, I can say, well, that's 4, that's fine, but this is going to break up to the square root of 3 times the square root of x squared. And of these two, only this one is a perfect square. So therefore I can write my answer. 4 was already outside the radical. This one's a perfect square, so now I can simplify that, which the square root of x squared is just x. And then this one has to stay within the radicand. That's not going to move at all. It's going to be inside the radical symbol. Okay, and so that is your simplified answer. All right, here's this last one over here. You can try to pause the video and try this one out by yourself. If you do that, you'll probably notice that this and that are both inside the radical symbol. So what I'm going to do is I'm going to start off with multiplying. The 3 is going to stay outside. Okay, it's like the coefficient, if you will. And then I will start to combine everything inside. So we got 7, and we got x squared, and we have y squared. At this point, I'm taking a look at it and say, I'm going to break this up into 3 different ones. The 3 stays outside, but I get radical 7 times radical x squared times radical y squared. And here I see this is a perfect square, and so is this. So those two get simplified. I get 3, which was already outside. This one gets simplified to x. This one gets simplified to y. And this square root of 7, well, that's not a perfect square. It has to stay within the radical symbol. And so there's that one right there. Okay? If you want to try one more for guided practice, go ahead and try this one out. Square root of 2x cubed times the square root of x. Try that one out and see what you get. All right, if you're done, then what I would have done is I would have gone, these are 2 inside, so I go 2x to the 4th. And I say, let me think. Well, this can be broken up to the square root of 2 times the square root of x to the 4th. X to the 4th, it happens to be a perfect square. Maybe you see it, maybe you don't. If you do see it, you can see that this part alone, since it's the only thing that's a perfect square, actually turns out to x squared, because x squared times x squared gives you x to the 4th. And then over this part gives you that. That has to stay inside. If you didn't see that, what you could have also done is you could have done this too, times x squared times x squared, right? And then you would have seen that this turned into x, that turned to x, hence that part, right? That stayed out there. All right, very cool. That's it.